Yeah. My name is Kristen Schroeder. I'm the General Manager and Deputy VP for Environmental Remediation Management with Canadian Nuclear Laboratories. And I'm really happy today to be here to talk to you about what we've been doing at Canadian Nuclear Laboratories over the last number of years. The focus of my presentation today will be managing Canada's largest nuclear cleanup portfolio. And I'll explain a little bit more about that as we go through the presentation. So I hope you enjoy. I will be taking questions at the end to answer anything that you are curious about or wanted to learn more about. So first off, just want to bring up to speed on who CNL is, Canadian Nuclear Laboratories. So we are Canada's national nuclear laboratory. Our head office is at the Chalk River Laboratories, which is just about an hour and a half northwest of Ottawa. We have a large campus here. It's about 9,000 acres. We have a number of laboratories and a wide diversity of staff that work here. We have a science and technology organization that has over 500 PhDs, and we do a lot of work here in support of the CANDU reactor and the maintenance and refurbishment of those reactors within Canada and abroad. And we also do a lot of nuclear research to support the industry, both nationally and internationally, as well as non-nuclear research. So there's a broad spectrum of work that we do at CNL, and particularly our Chalk River Laboratories. And some of that has been the focus for the last 20 years has been on the environmental cleanup, and that will be what I'm going to speak to a little bit about today. Just a couple things to note. CNL is about 3,500 staff working across our various locations. One important thing to note is how CNL is structured. CNL used to be known as Atomic Energy of Canada, or AECL, but back in 2014, we transitioned to Canadian Nuclear Laboratories, and that's because we went underneath a new structure for the delivery of work at the CNL sites. We are currently operated under a GOCO, which is a government-owned contractor-operated structure. And this slide sort of depicts how we are managed and overseen by both Atomic Energy of Canada, which is a much smaller organization now, of about 40 people. It's a government organization that provides the oversight and funding for Canadian Nuclear Laboratories. We have a contractor that operates our CNL sites. That is currently CNEA, Canadian Nuclear Energy Alliance, which is operated by Jacobs, Fluor, SNC-Lavalin, and Atkins. So the contract for the operation of the site is through Atomic Energy Canada Limited. And then CNL is the enduring entity that holds the site licenses with the Canadian Nuclear Safety Commission for the safe operation of our sites. So this structure you would see, it's a structure that's common in the US at some of the DOE sites. It was a common structure in the UK, but they have reverted back to a different operating structure. But this is the structure that we are operating underneath at Canadian Nuclear Laboratories. I wanted to talk a little bit about our strategic priorities and our Vision 2030. So we have three strategic priorities for CNL. Restore, protect Canada's environment, clean energy for today and tomorrow, and contributing to the health of Canadians. So these are all three key things, three key areas that we're focused on for the betterment of Canada and the international community. Today, my presentation will focus on restore and protecting Canada's environment, which is the area that I'm focused on. This is a map of Canada, and it provides really an overview of the environmental management mission scope that we're delivering here at CNL. As you can see, we've got sites across Canada, with a lot of them focused more in the Ontario area, down at the bottom. The scope of work that we deliver underneath ERM, or Environmental Management, is focused on decommissioning, cleanup of our nuclear facilities and non-nuclear facilities, environmental remediation, which is the cleanup of our soils and plumes at our various sites. We manage radiological and hazardous waste. So we have a waste program that we implement in order to safely manage all nuclear and non-nuclear waste. And then we have, on behalf of the Canadian government, cleanup of historical low-level waste sites. And these are some of the sites that you'll see on the top left of the picture: Sawmill Bay, Great Bay River, Hay River, Greater Toronto area down at the bottom, as well as the Port Hope and Port Granby site. And I'll talk a little bit about those as we move through the presentation. At CNL, all of our work begins with the end in mind, and we follow an integrated waste strategy in order to plan and execute our work. You can see on the left-hand side our strategies and how we deal with waste. The first is we always want to try to prevent generating waste. Then we want to reduce. If we do need to generate it, we'd want to reduce how much we do generate. We want to reuse waste in different formats any way we can, recycle that. And the last alternative is to dispose. So these are the sort of principles that we follow in managing our waste. And you can see on the right, how we move through our structure and our planning in order to incorporate waste, being in an ERM, environmental remediation management. What we do is deal with waste on a daily basis. So it's important that we have a strategy that sort of guides us as we work through that to ensure that we are meeting our corporate policies as well as our regulatory documents and frameworks that guide our work. So everything from planning and preparation, you can see here how we always look at inventories, waste characterization, waste management plans, so we understand how we're going to do it. From a generation standpoint, we have multiple areas where we generate waste. From an operational standpoint, because we operate the labs, through our decommissioning and cleanup work, and then we're doing legacy work as we're legacy retrievals as we're dealing with waste that has been may have been stored at the site previously from the long history of operation. Getting into some of the specific updates for some of the work, I'm going to start at CRL or Chalk River Laboratories. And this here on the right is a map of our Chalk River site. You can see the pink area. On your left screen is our controlled area. This is more of our area where we have our radiological structures, laboratories and facilities. And the lighter yellow area on the right is is just the support facilities and structures around our controlled area. It's important to it's important for me to say, and I'm really proud that since 2015, and we go back to 2015 because this is the time frame where we switched from a government organization to a government owned company operated organization. We have demolished 111 structures at our Chalk River Laboratory site. And I'm not going to go through all these numbers, but you can see, the large values in footprint reduction across our site, the amount of asbestos waste because of the age of the buildings that we've had to deal with, the amount of low-level waste, intermediate level waste, and most importantly, the largest number is the amount of waste that we have cleared to go off-site, either through recycling or through reuse. The color scheme on the pictures, red is the demolished facilities, the facilities that we've already demolished. And you can see a large volume on the right-hand side as we've been focusing on cleaning up a number of those areas in order to support new construction at our site. And the light green ones are the ones that we are planning on having demolished by the end of the GOCO period, which is the 2025. This slide gives you a little idea of some of the work that we're undertaking as part of our decommissioning cleanup work at the Chalk River site. You can kind of see through the various pictures, as part of our demolition and getting ready buildings for demo ready, we're removing all of the drywall. This picture on the left is sort of depicting some of the asbestos abatement work that we needed to do. We get into some very hazardous work, as you can see in the bottom left corner, where we're dealing with glove boxes, where we need to have our staff protected through various PPE and respirators to do work. The top right picture shows, some new ways that we're looking to get access to our existing facilities. Here we've got some specially designed modified sea containers that we've put up to a foundation wall to enable us to remove waste from the basement of a facility. The only other way to get the waste out of there would be through a small access hatch in the floor. So we look at ways of how we need to modify facilities in order to remove waste so that we can reduce the hazards in these facilities and ultimately demolish the structure. Picture on the right just shows you our predictions for the amount of buildings that you would have seen in the last picture to demolish over the next few years. So as I mentioned, we're currently at 111 structures up until the end, till March of 2022. And by September 2025, we expect to be at 150 buildings demolished at our Chalk River Laboratories site. So a lot of work is being done to deal with the legacy and the hazardous structures that we have at our Chalk River Laboratories site. One of the key projects that's actually enabling all of this decommissioning work that we're looking to put in place is a disposal facility at our Chalk River Laboratories site. This is referred to as the near surface disposal facility. This is going to be a low-level waste facility that is designed to hold 1 million cubic meters of low-level waste. This low-level waste, about 90% of this waste is currently at the Chalk River Laboratory site, whether it's already been generated and it's stored in some of our waste management areas, or as part of our operations and decommissioning work being completed over the next 20 to 50 years, that waste will go into this new disposal facility. We are currently in the licensing process for this facility. So we have an environmental assessment that we've prepared for this, as well as a licensing package to support including this new facility as part of our Chalk River license. We've completed the first part of the hearing process, and later this spring, the end of May, we move into the second part of the licensing process. And if we are successful in our licensing process, we expect to start construction early in 2023, and it's about 4 years of construction before we go into operation. This facility is designed to operate for 50 years, which is sufficient time to deal with all of our legacy waste and the decommissioning of our facilities moving forward. So this is a key project that will help CNL move forward with their decommissioning activities at the Chalk River site, as well as some of our other locations. Another key project for us is the White Shell Closure Project. This project, if you remember on my Canadian map, it's kind of in the central of Canada. The White Shell Laboratory operated from the early 60s and was operational until 2002. This site, the White Shell site, is under closure. So when it shut down in 2002, since then, what we've been doing is getting the site ready for closure, doing our characterization, starting to tear down our redundant facilities at the site. So there's been a lot of work that's been undergoing at the White Shell Laboratories. It's in Manitoba in order to prepare this site for final closure. This picture on the bottom left is kind of our central campus. And it looks a lot different now. As you can see, there's a lot of green space. There used to be a lot of facilities there that have been torn down in support, that we were previously there in support of the site, and we continue to work to advance the decommissioning of these remaining facilities. And then we're going to move on to our waste management areas. We have that site operated for more than 40 years, so there was a lot of waste that was generated, and we do have a number of waste management areas. We call them standpipes that would hold some intermediate level waste, and bunkers that would have a mixture of either intermediate level waste or low level waste. And in this bottom picture, you can see concepts for some equipment that is actually under fabrication now, and some of it's already fabricated and in testing for new facilities that are being designed and built to support the remediation of these waste management areas. So we will have specially designed equipment that will remove waste from the standpipes, those little round circles that you can see in the picture, as well as specially designed equipment to remove waste from the various bunkers where we have a mixture of intermediate and low level waste stored. So this is a really exciting project. It's going to be the focus at the Whiteshell Laboratories over the next few years, and we're working closely with the supply chain in order to design and build the specially designed first of a kind equipment for use at CNL as well as in Canada. The Port Hope Area Initiative. This is the project that deals with historic low-level waste, low-level radioactive waste that I spoke to earlier. This waste was not generated as a result of CNL activities. It was actually from another corporation called El Dorado Nuclear Limited that operated from 1933 to the late 80s. And this El Dorado, they mined radium from the north of Canada, and they shipped it down to Port Hope, where they would refine it. As a result of these historic operations, there has been some impacted areas, and the low-level radioactive waste here is predominantly soil, but it is present throughout the Port Hope area, whether this be in people's backyards, whether this be wood that was previously used at some of the refinement that was used to build some people's homes. So there is contaminated wood in people's homes. It is an extremely interesting project that will result in about 1.7 million cubic meters of low-level radioactive waste safely stored in long-term waste management facilities and protected to protect the environment as well as the residents in this area. So this is a multi-billion-dollar project. It's been ongoing for many decades already as we were working through the characterization and gaining the agreement with the community on the cleanup plan. In the last decade, we have started the active cleanup, and we've actually already completed all of the work to support the Port Granby project. That's the bottom left picture where we've already remediated 1.3 million tons of low-level radioactive waste that was close to the Lake Ontario shoreline. That radioactive waste and soil has been removed and put into this newly designed long-term waste management facility. The bottom middle picture is another interesting part of this project, and this is the Port Hope Harbor. Unfortunately, I don't see any boats in there right now. CNL is now managing the harbor. We are dredging all of the sediment at the base of the harbor, and that's what you can kind of see out in the water. There is some dredging equipment, and we are going to be dredging all of the sediments in there. This project just got underway last year, or 2 years ago, I apologize, and it's expected to be completed in the next few years. The bottom right one is, I just want to kind of give you an idea of, this is, a little tiny excavator working in someone's backyard, digging up soil from someone's backyard. One of the challenges, we call this a small scale sites, because everything is just in people's backyards. So you have very minimal space to work. You can't bring large heavy equipment in there. So we utilize, small little excavators or backhoes in order to help with the remediation. And this is a really interesting part of the project. We're just getting underway with the remediation of these small scale sites, which are across the community. We have about 800 of these locations in order to clean up. And it's a challenge for our staff, our contractors, and the community to have to work through this remediation, but it is going well, and we're getting good support from the community. Important thing is, in the next 7 or 8 years, when we've completed this project, is that there will be, significant environmental benefits for the community. All of the low-level radioactive waste will be safely stored within 2 long-term waste management facilities, one in Port Hope and one in Port Granby. Health and safety is extremely important in everything that we do at CNL, particularly in our ERM program. And I wanted to kind of talk a little bit about that. And this is really related to the type of resources that we bring on and ensuring that we've got the right amount of staff supporting the work. This picture here in the bottom left shows, some of the technology and tooling that we're utilizing in order to support some of our decommissioning activities. A lot of times we have our staff hands-on doing the decommissioning work, depending on the hazards involved, whether that be with mechanical cutting equipment or removing waste. Sometimes, depending on the nature of the work, if it's more hazardous or if it's safer to use machinery. This bottom left picture shows just the edge of a Brock unit, which is a remote operated piece of heavy equipment that can be small, that goes inside of buildings, that can safely remove the worker from the hazard in order to do the work. So there's different types of tools and technologies that we'll utilize in order to safely execute our work, whether that be safer for the worker or safer for the environment, depending on the hazard that we're dealing with. All of this work we deliver through an integrated work control process, which really is just ensuring that we've got all of the key programs and input into our work planning as we progress. That is, the operational requirements, that could be requirements from our fire protection program, our environmental protection program, our radiation protection program. Really, all our requirements are integrated into one package to ensure that we are safely delivering our work. On the right-hand side, one of the benefits of delivering our ERM program at CNL is the ability to access and tap into all of the great research and the science and technology that CNL offers, both nationally and internationally, as commercial work and in support of the Canadian government. By having access to these researchers, to this technology, we're able to, bring some of the problems that we come up with, that we come up against in the field, and work with our scientists and technologists to identify opportunities or ways, solutions that we can safely manage this waste, safely manage this issue that we've come across. So we are implementing what I would call an active demonstrator project program, as through a lot of our work. Once we develop the new technology, we can then have the opportunity to test this in a radiological environment to demonstrate that it is effective for use. And then this is sometimes OPEX that we would share with the industry, or sometimes this is technology that we would deliver through commercial arrangements, depending on our clients. So an important aspect that we're really blessed to have is this science and technology team that can help us solve some of these problems as we move forward. Indigenous relations. This is a critical part and critical aspect of the delivery of our mission here at CNL, and particularly in an environmental remediation management mission. Canada is committed to reconciliation, to doing what we can to have meaningful engagement with our Indigenous communities. And at CNL, this is an extremely important part of our delivery of our work. As part of our various projects, we have a lot of opportunities to have engagement with local Indigenous communities through our environmental assessment process, through our environmental programs and our cleanup programs at the Chalk River site, as well as our White Shell and Douglas Point site. So being able to have meaningful engagement and apply traditional knowledge to our projects is key for the success of all of our work in ERM, as well as our work at CNL. Also, along those same lines is communications that we have with our stakeholders. We follow a process of inform and involve, and we do everything we can in order to continue to build that trust with our local communities and get them involved and informed about our work, such that they have an opportunity to provide input, share concerns with us, and help shape some of our projects. So our public information program is really strive to ensure that we have timely dissemination of our project information, that the information we provide is accurate, reliable, and most importantly, understandable. Sometimes we get it stuck with providing too much technical information, and we need to make sure that that information can be easily shared with our community. You'll see here a list of various ways that we continue to inform and involve the public, whether that be through webinars, community events, tours, and open houses. Actually, this summer, we will be having an open house at the Chalk River Laboratory site. So if you've ever had an interest to come visit the site, we do have an open house this summer. So you have an opportunity to check out our website and register for that open house. So there's a lot of things that we're doing in order to engage and inform the community that we work in, because it's such a critical aspect of our success. And I think I'm going to end there with my update and bringing up to speed on some of the environmental work, cleanup work that's happening across some of our CNL sites. Here is just a listing of all the different ways that you can find out more about us or follow us on all the work that we're doing. So look forward to your questions, and thank you for your time.
Hi, Kristen. Thank you again for a fantastic presentation. It's great to have some perspective from Canada. I found that really interesting, so thank you.
No, thanks, Caroline, and I appreciate the opportunity to speak here today. So,
we've already received quite a few questions from our audience, so I'll just kick off with those, if that's okay.
Absolutely.
So early on in your presentation, you had a map, and you mentioned that you were demolishing buildings at the Chalk River site. But I just wondered, can you give a bit of an update on what kind of construction do you plan at the site, and what will you be using these new facilities for?
Yeah, no, great question. One of the key reasons that we're doing a lot of cleanup at our Chalk River site is actually to support site revitalization. So as part of the GOCO arrangement that we have operating here, the government announced $1.2 billion in site revitalization. And we have already built a number of buildings, and we have new buildings coming still that are underway. So just kind of giving you an idea of some of the new construction that's been happening in the last 5 years. So we did build a new laboratory complex that was just built. We have a science collaboration center that is probably about 60% built already. It's all framed up, and we're moving forward with putting the windows in. And we're just about to break ground later this summer on a new hot cell facility called our Advanced Nuclear Material Research Center that is also being built here. There's also some facilities being built to support our cleanup program. So we have a new detritiation facility that's being built to deal with our treated heavy water that we need to deal with, and a cask loading facility that's being used because of the amount of shipments that we have between our various sites for the intermediate high-level waste. Is just sort of managing and maintaining these casks. So although we're tearing down a lot of buildings and shrinking our footprint, there's still a lot of new construction happening to support the science in some of our cleanup activities.
Fantastic. Thank you very much. On the waste side, I'm jumping a bit, but we've had a question relating to the volumes and types of materials that you've reused or recycled as part of the decommissioning process. And obviously this is a key issue that's come up throughout today. And I wondered if you can share some more info on, you know, the volume and types of material you've been reusing.
Sure. So we don't have it necessarily in volumes. I have it in weight, just because of the way we track it. So on one of the slides, and I have the number here. So we have over 19 tons, or 19 million kilograms. So 19,000 tons that we have generated in clean waste through our decommissioning of these structures, 111 structures so far. So we do recycle as much as we can from that. You know, exactly what is the percentage from recycling to disposal, I couldn't say, but it'd be in the high 80s, because, you know, a lot of metal gets recycled from our facilities. What we're doing for reuse, because a lot of the metal we can't reuse. For reuse, any facility that gets turned over to our group, we go through POCO operations, post-operational cleanup, and we try to reutilize anything that's that is left in that building that is salvageable for reuse. But where we see the most reuse is actually in our concrete. So we have a lot of the concrete foundations. We are crushing that concrete, removing any sort of rebar to recycle the metal, and then reutilizing that concrete for whether it be roadways on our site or for backfill into some of our excavations. So do everything we can to reutilize our waste. We recently started to recycle asphalt. That's not really in our decommissioning, but more in our cleanup program. When we have to dig up asphalt, we're starting to reutilize that with a local supply chain as well. So.
Brilliant. Thank you very much, Kristen. So with the waste that isn't recycled, you mentioned that you're building the near surface disposal facility, or hoping to.
Yep.
And I just wondered if you can share a bit more detail on whether this is going to be receiving waste just from the Chalk River site, or if it's going to be receiving waste from other sites and other decommissioning projects that you've got.
Yeah, no, good question. So our near surface disposal facility, as I mentioned, it's going through the licensing process, and the second hearing starts in less than 2 weeks, the second part of our hearing. It's 1 million cubic meters, and about 90% of that material is already at the Chalk River site. So that is either in our storage waste management areas, from the 40s to now in storage, or these are structures that still need to be torn down as part of our ongoing operations, whether that be through decommissioning or our S&T work. And the other 10%, approximately 5% of that is coming from, a little bit more than 5%. The other 10% is coming from our other AECL-owned facilities, so the ones that CNL operates. So that would be our white shell laboratories. There's some of that low-level waste that's coming back that will go into the near-surface disposal facility, as well as some of our prototype reactors, Douglas Point and John C1. Outside of AECL-owned waste or government-owned waste, it is we do take waste from hospitals, local hospitals, and local organizations, and do medical isotope production processing. So we do not accept waste from other utilities, but we do from the local hospitals, some of the universities, and some of these medical isotope production operations to support the Canadian healthcare or education industries.
Okay, we've just actually received a question in, and I think it relates to this facility. It says, would you be able to accept norm waste?
So if the waste is norm, so it would, not necessarily need disposal in SDF, right? We might have other ways that we would deal with that. So, we manage norm waste here, but it's not necessarily something we would import in from other sites on that. So.
Okay, thank you for clarifying. Now we're moving on to the backyard cleanup operations. experience of affected communities. And we've got a question from one of the members of the audience. How and whom did you approach in the community to obtain the approval for the digging, the backyard digging, and how did you manage the communications? I mean, this is a key issue, so.
Yeah, this is a really interesting project, and the project probably started 25 years ago when it was recognized in the community that they had, this issue with, they had the local, the residents had reused material from the El Dorado company, whether that be soils or building materials in their backyards, in the construction of their sheds or their decks or parts of their house. And it had very low levels of contamination associated with the processing of radium. So throughout the last couple of decades, we've been working with the community to develop a plan in order to deal with this. So this is something that the community recognized that they need to deal with, and that's when the idea was to build this this long-term waste management facility within their community. There's 2 communities we were dealing with. In the Port Hope community specifically, it's within their area. So the residents, everyone had their home surveyed or their lot surveyed across the whole community so that we can delineate where there was a contamination. And so all of the homeowners are aware of, do I need some remediation done in my home, or is my home free and clear of any sort of contamination? So they're aware of the need to remediate soil or part of something in their house. So that is coordinated through our communications group. We have a large communication stakeholders team that works with the community members based on our schedule on when we're going to be coming in to do some remediation. We work with them as best as possible. They might have a wedding going on in their backyard, so we don't want to be interrupting that, right? So there's different things. It's a lot of coordination, a lot of work through our communications and stakeholders team in order to manage that.
Amazing. Yeah. Well, I mean, as you said, like disposal, projects can be challenging, and it's great to know that you've got that kind of communications in place. I'm going to jump a bit. We had another question, and it's related to the equipment that you're designing for use at Whiteshell and C&L. And somebody's asked, are these robotic machines? And could you shed a bit more light on what kinds of machines and systems that you're developing, please?
Yeah, absolutely. The equipment that's going to be used at Whiteshell to clean up the waste management area, specifically the standpipe and bunkers there, is all remote. So there will be operators that will sit in a little trailer. Everything will be camera, and then the system that we're working with the supply chain on, it's there's multiple different processing technologies, but essentially you're going to have some robotics or remote capabilities to do some digging, and then you're going to have some whether they be pinchers or to pick up material. It's then going to be able to put it into a bin so that we can shift it over and do the scanning to identify what sort of material do we have, because we do have a wide range of research material that's in there that we need to be careful about. Fissionable material, what type of contaminants or radiological material we're dealing with, in order so that we know what to do for the disposal or storage. So all of that will be remote, given the uncertainty in the waste type as well as the radiation fields that we're expecting on some of the standpipes or some of the bunkers.
Okay, brilliant. I think we've got time for one more question, and I'd like you to talk a bit more about the government-owned contractor operated model, and
Okay.
What are the benefits that you've seen using this model at Chalk River?
Yeah, good question. There's there's some personal benefits that I've seen through the GoCo, and that is in the area that I work in with the cleanup. It's been a heavy focus of the GoCo in its first contract. So there's been I've had a lot of new bosses that have come in. As people are aware, sometimes the cycle for the GoCo is a 3-year. You come in and they go through a cycle of individuals to support. But I've had a lot of bosses they've learned a lot through their experience, whether that be in the UK and some of the cleanup machine that's being undertaken in the UK or from the US. So, you know, from a mentoring and knowledge standpoint, it's been great to have, you know, someone there that's done this before or has contacts that has done this before in the US or the UK, and we're able to tie into that in order to help our program. I think it's really helped us to accelerate our mission because in addition to having that mentoring myself, but it's also been on some of the strategy to help move some of our projects forward and where we've done this before, and just the ease of benchmarking, where we can go visit some of their sites where they're actively doing some of the similar work, so that we can take away from that and apply that to our program here at CNL. So those are some of the key things that I've seen myself.
Thank you very much for that, Kristen. I think we'll leave that there, and that will conclude the event today. I just want to say thank you to all the speakers and all of the sponsors, Shadow Robot, for allowing this event to go ahead. But thanks for joining us. There's still an opportunity for you to enter the networking area and to visit our sponsored pages, so please feel free to do that. And on a personal note, I just wanted to say thank you to everybody, because it's actually my last day as editor of Nuclear Engineering International. So thank you to all my contacts, the readers, advertisers, subscribers, and you know, the sessions for this event will be available on demand. So please feel free to continue to share. And thanks very much.